Hello everyone, my name is Erin Anderson and today I'm going to introduce you to Groovy. This is the language I chose for my final project in Programming Languages CS360. It's a language that sits at an interesting intersection between Java, scripting languages, and modern dynamic language features, and I'm excited to walk you through what makes Groovy both fun and practical. Here's what I'll cover in this talk. First, I'll introduce what Groovy is and why it exists. Then I'll move into the syntax and key language features. After that, I'll explain how Groovy is parsed, compiled, and executed under the hood. I'll compare it to languages we studied in this course. I'll show two short demo programs, a CSV summarizer, and a small DSL. I'll also share how I learned Groovy, and finally wrap up with when and why people use Groovy in real projects. Groovy is a dynamic and optionally static language that runs on the JVM. One of its biggest strengths is that it's fully compatible with Java, so anything Java can do, Groovy can do, often with less code. It's used for scripting, automation, build files, and creating DSLs. Even though it's beginner-friendly, it also has powerful metaprogramming features that let advanced users extend or modify behavior at runtime. One of the first things you notice in Groovy is how much cleaner the syntax is compared to Java. You don't need semicolons, and parentheses are often optional. Groovy adds features like G-strings, where you can easily embed variables into strings. It has built-in list and map literals, and it uses closures, which are similar to lambdas but more flexible. The goal is to reduce ceremony and let you focus on the logic rather than the boilerplate. Groovy is dynamically typed by default. That means you can declare variables with def and their types will be determined at runtime. But Groovy also supports optional static typing. You can annotate functions or classes with compile static to enforce strong type checking and get Java-like performance. This gives you the best of both worlds, the flexibility of Python and the safety and speed of Java when you need it. Groovy's language pipeline looks a lot like other languages we studied. Source code goes through a lexer, then a parser that builds an AST. Groovy is special because it supports AST transformations like immutable or compile static, which actually modify the tree before compilation. Then Groovy generates JVM bytecode. It can run interrupted scripts or fully compiled classes depending on how you use it. This dual nature makes it very flexible. Here's an example that shows lists and closures. The collect method transforms a list by applying a closure to each element, here doubling it. Closures are one of Groovy's most powerful features because they allow concise iteration and transformation without the overhead of Java's verbose syntax. This makes Groovy excellent for scripting and data processing tasks. The first demo is a CSV summarizer. This program shows how Groovy handles file I/O, how it uses lists and maps to store data, and how closures make transformation simple. Here's my CSV summarizer in Groovy. You can see we get the CSV file, we're splitting, and then we have our print lines that it will print out. And we will just go ahead and run that. You can see that it runs well, and then we can look over here at that data file, name, Aaron, Alex, Sam, so it's giving us those numbers. And then for our second demo is a mini DSL, a domain-specific language. Groovy is famous for this because Gradle itself is written using a Groovy DSL. Features like method missing, closures with delegates, and dynamic dispatch allow you to create readable English-like configuration languages. And here is my mini DSL. You can see it's pretty short. We've got our task runner, our compute, greet, and goodbye. And then our closure, and you can see where it runs script and DSL run all. We will just put that right in, mini DSL, and run it. And you can see there at the bottom that the running task, greet, hello from DSL, and then it does some computation and says goodbye. So compared to Java, Groovy is far less verbose and much more dynamic. Compared to Python or Ruby, Groovy feels similar in flexibility but stands out because it fully interoperates with the JVM ecosystem, and compared to C#, which is strictly typed, Groovy gives you the option to be dynamic or static depending on your needs. This makes Groovy a bridge between scripting languages and enterprise languages. To learn Groovy, I relied on the official documentation, Stack Overflow examples, and experimenting inside the Groovy console. I also learned a lot by reading Gradle, build scripts, and using AI assistants to clarify syntax. Overall, Groovy was easy to start with, but it has deeper concepts like DSL creation and metaprogramming that will reward going further. Groovy is used heavily in Gradle build files, automation scripts, and rapidly prototyping. It's also great for writing DSLs, and it can replace shell scripts in JVM-based systems. Even though languages like Kotlin are more modern, Groovy still has a strong niche because of its flexibility and its simplicity for scripting.